I'm an AI/ML Specialist Solution Architect at AWS. So, this is a level 300 session, and the agenda is simple. I'm going to talk about foundation of ML Ops and share some of the learnings and lessons I've gained working with many customers. Marcus will talk about Rio Tinto's journey and how they've approached ML Ops. We hope that you walk away with clear direction on how to get started with your ML Ops journey and what areas to look for. Marcus, over to you.
Thank you, Romina. My name is Marcus Rosen. I lead a team within Rio Tinto that focuses on architecture and development of machine learning solutions on AWS. The core mission of my team is to optimize the delivery experience of our data science teams to make their lives easier and not get too bogged down into infrastructure and security issues. And we do that by working directly with those teams and with our cybersecurity team to build a secure but flexible delivery environment. Now, Rio Tinto is one of the world's largest mining companies, and we find better ways to provide the materials the world needs to grow and decarbonize. We own and manage a portfolio of world-class assets within areas such as aluminium, copper, lithium, iron ore, and titanium dioxide. In 2023, we turned 150 years old, and we take our names from the Red River mines of southern Spain, where our first mining rights were issued. Rio Tinto's operation spans 6 continents, 35 countries, and we employ in excess of 55,000 people. As you can see on the map here, we have a presence across most of the planet, but when it comes to delivery of machine learning solutions, we work predominantly out of 4 different hubs. Brisbane, close to our assets, our aluminium assets in North Queensland. Perth, close to our iron ore assets in the Pilbara. Singapore, where our commercial business lives, and Montreal in Eastern Canada. We've also, over the past couple of years, built a specialist team in India to deal with productionized machine learning solutions. Now, various teams at Rio Tinto have been using analytics and delivering solutions across for a long time, especially within optimization and simulation. About 7 years ago, we made a strategic move to deliver a dedicated machine learning capability to bring together a new team with an expert from across Rio Tinto to work across our lines of business and product groups to help them deliver machine learning solutions. Now, growing a central analytics capability in a company like Rio Tinto, where every single product group is really a large business, is quite a difficult task. And one of the challenges that we faced was that the key resources used to deliver these projects, your data scientists and your data engineers, really need to understand the data they're going to be working with. They need to understand the data sources, the data structures, the data velocity, and any constraints. They really need to understand the business in general. And so with that in mind, we use what we call the franchise model now, where our products group and line of business actually hire their own data scientists and data engineers, and they sit embedded into those businesses. Underpinning that, we have a center of excellence model where we provide the tool and machine learning environments on Amazon SageMaker. We provide architecture and security support, so we take the teams through those governance processes, and we also, in some cases, help them with DevOps and automation depending on the project requirements. Now, over the years, our teams across the world have delivered many different use cases. And one area where we've delivered models is within predictive maintenance. Now, Rio Tinto is the owner of the world's largest private rail network, and we use the rail lines to deliver what we dig out of mines to the ports. And any disruptions on the line can cost us a lot of money in financial penalties. So this model runs on a sliding window basis and is able to predict about 7 weeks out if there needs to be maintenance done on a certain parts of the track, which can cause delays. With that information at hand, the planning team can then either schedule around that part of the track or fix that problem before it occurs. Another use case is around health and safety. And here our team in Montreal have built a model to predict the likelihood of a water leak occurring in an industrial smelter. If water drips into an industrial smelter, which is extremely hot, it can cause a buildup of hydrogen gas, which is extremely explosive, can cause the loss of lives, damage to equipment, and shut down of the entire plant. Now, this model runs on an hourly basis and produces a risk rating, which is fed into the risk management process of the plant. And lastly, we have habitat management. Now, as a large miner, we take our ecological responsibility of our mine sites extremely serious. And we've been using machine learning to help recognize and manage the animal habitats around those sites. An example of this is the palm cockatoo hollow monitoring program in northern Queensland, WEPA, across our aluminium site. The palm cockatoo is an endangered bird that breeds across large tree hollows around the site. And by using cameras and feeding the images from those cameras into computer vision models, we are able to track breeding patterns of these birds and help build a presence of where they're located across the estate. That information is then fed into the planning process of the mine to help avoid and disturbing those habitats. Now, as we scale machine learning more and more across Rio Tinto, we need a more standardized approach for delivering models and deploying them. Hence, machine learning operations, or MLOps.
I've had the chance to speak to many customers, listen and learn about their challenges, and evaluate their approaches. So to set the foundation, I want to share some of the patterns I've seen globally and some of the key insights and learnings I've gained out of all those conversations. To help us understand why we need MLOps, I want to quickly walk you through the machine learning development process. We start a machine learning project because we have a business problem we want to solve, and we've determined machine learning is the right approach. Then, a data scientist starts by collecting, cleaning, and analyzing data from various sources. They engineer features, train multiple models, and evaluate them to pick the best one. Depending on how the models are performing, the data scientist might go ahead and perform additional data steps. But assuming the model is performing well, the data scientist will go ahead and deploy that model to generate predictions. Critically, the data scientist will also need to monitor that model into production to ensure it retains its accuracy over time. The machine learning lifecycle I just walked you through is fairly complex and iterative. And as the organizations grow, you will have more specializations of roles across this workflow. Instead of one data scientist going through every step themselves, the responsibilities get divided up. And it might look something like this. A data engineer will create data pipelines. Data scientists will experiment and develop models, train models, but models do not go straight to production just like that. You will have a model evaluator who will check the model against your business KPIs. They will also check for the potential bias and fairness issue with the member of your governance teams. Once approved, then the model is taken to production by MLOps or your DevOps engineers. The governance team will continue monitoring the models into production. Now, I recognize many of you might not have all these dedicated roles for these steps. But the key that I want you to understand is, as your team grows and you have more roles and responsibilities, they all have their own KPIs, they want to follow their own processes, and they want to use their own tools and technology. Challenging situation you're all too familiar with? So without the well-defined processes, for the skilled personnel to follow and the supporting technology to enable manual workflows to get automated at a scale, bottlenecks can arise. The outcome will be declining productivity of your machine learning teams, deteriorating the model performances that can go undetected, and rising cost. And that is why we need MLOps. So what is MLOps? MLOps is a set of operational practices combined with people and technology to productionize machine learning at a scale efficiently, ensuring governance and compliance. The key phrase that I want to revisit is operational practices. So MLOps, just like DevOps, is more than a set of tools and technology. It's a philosophy that fosters a collaborative culture between your team members. So remember, tools alone will not cut it. Technology is there to simplify and streamline these practices, making the job for your teams easier. Now that we've understood our people and processes, we can think of what technology and tools to provide them. Let's break it down. The platform administration teams, they need tools and environments to provision infrastructure, to define user access, to create environment as configurations as code. Our data owners and engineers, they need tools and environment to create and curate data pipeline and data catalogs. Data scientists need sandbox account to experiment. Together with the machine learning engineers, they need automated workflow tools for model build, testing, and deployment steps, followed by monitoring. Governance teams oversees it all with their own specialized tools. Now, let's translate this into a technology that empowers every role. Let's create an experimentation account for our data scientists first. We see in this architecture, we have Amazon SageMaker Studio, which is an integrated development environment for capabilities for end-to-end machine learning process. Data scientists have access to a number of tools, including various data sources curated and made available by data engineers, such as Amazon Redshift, which is a data warehousing solution on AWS, and Amazon S3, simple storage service on AWS. The data scientists develop models, and once they've come up with that final model, the code of the validated model is committed to a code repository for the version control. In this architecture, AWS is code commit. Then, in collaborations with machine learning engineers, the codes are refactored in the production-grade code, and that is the source where the automated model build pipeline can be orchestrated. In the model build environment, we can see that we're using Amazon SageMaker Pipeline, which is an integrated workflow tool to create your machine learning workflow, orchestrated with the AWS's code pipeline for the CI/CD. The outcome of this automated model build workflow is the model built and registered onto the SageMaker model registry, which then a model approval will evaluate and approve the model. Once approved, that will trigger the automatic deployment of the model into the testing environment, orchestrated by the CI/CD tool of your choice, in this architecture, AWS's code pipeline. Your model approver, that can be your lead data scientist or product owner, again will evaluate the testing results, such as unit, integration, and load testing. Once approved and passed all those tests, the approval will automatically deploy the model into the production environment. In this architecture, we have also enabled model monitoring using Amazon SageMaker Model Monitor, which help us to monitor the model against concept and data drift and issue a trigger, which can form our trigger for starting the retraining pipeline. The multi-account structure I just showed you offers several key advantages. It provides separation of concerns, improved governance and security, isolation, scalability, and collaborations between team members. So it is very important to remember, while we enable the separation of concerns, the key to success relies in well-defined processes and collaborations between team members. Now, as organizations grow to the size of larger enterprises, like what Marcus mentioned, additional standardization control will be desired. So in this architecture, we have moved all the CI/CD pipeline into a central account. We've enabled a central SageMaker model registry and a central Elastic Container Registry. And also we're utilizing AWS Service Catalog that can host a number of templates that can provision consistent, repeated data science and CI/CD workflows and environments across teams and projects. We have a separate account for managing the data with our data engineers and users. Separate account for collecting logs, as well as providing observability for our governance and audit teams. I showed you a couple of different architectures. So which one is better? Well, the truth is there is no one valid approach or architecture to MLOps that works for everyone. Some of the things we've touched so far, such as organizations' compliance and security processes, model governance and monitoring requirement, your team structure, data access and management, they all play a crucial role how you go about implementing your MLOps. I showed you example of a couple of architecture. The first one was a more decentralized approach where each of the data science team, they were the owner and looked after their own CI/CD pipeline, whereas the latter architecture, a more centralized approach was desired where a dedicated MLOps team was looking after all the CI/CD pipelines across teams. Now, let's see how Rio Tinto has gone about their implementation.
Thank you. All right, so as a large enterprise, a quite siloed enterprise, we face a number of challenges delivering machine learning solutions. And one of those challenges is access to data. I think that comes to no surprise by no one. Obviously, if you don't have good data, you can't build good machine learning models. And getting access to data can be difficult. We currently have actually multiple data lakes, and trying to get access to data can be a bit difficult. Now, another challenge can be around networking. All of our production accounts are completely air-gapped. They have no internet access by default, and any internet access or any actual access outside of the account needs to be whitelisted through a centralized firewall. Some teams, though, need to access data sets that are internet-based, for example, satellite data sets that are really too big to bring into one of our data lakes. So we need to be able to enable that access in a timely manner. Around productivity, we need to be able to give our staff enough access to be able to deliver their projects and work day to day, but we don't want to compromise our security posture at the same time. And lastly, we need to start catering more to our growing number of citizen data scientists, so people who are quite coding and data literate users in enterprise. We have a lot of engineers at Rio Tinto, and many of them are skilled in Python and R and know how to visualize data, know how to analyze data, etc. And they want tooling to be able to investigate various machine learning use cases. Now, to tackle some of these challenges, we have a pretty standardized machine learning environment approach. One thing around the networking is we are very heavy users of private link endpoints. Because we have air-gapped accounts, private links allows us to get to AWS services securely and quickly, and we use a standardized policy agreed with cybersecurity around that. We also deploy them through the automation platform, which I will discuss in a little bit. From a firewall point of view, when we do need to leave our VPCs and go through the firewall process, we currently have a traditional firewall process, fill in a Word document, create a ticket, attach it, send it off, wait a week, 4 weeks, sometimes longer. And we're currently working on replacing that process with the team at RD11 actually, to a GitOps-based process where a central change to firewall rules will be done, raised at the pull request to our cyber ops team. They will then review those rules and approve them, and the firewall change will then be implemented in close to real time using pipeline type technology. From a security point of view, we use role-based access control using IAM Identity Center or AWS SSO. And we use generally off-the-shelf policies here. So what comes with the AWS managed policies? We then use service control policies at the organization level to remove some of the more sensitive operations from those policies. This makes the policy situation much easier. There's not a lot of complex conditions, and we also get support for new services as they are released. The service control policies themselves are reviewed frequently, and we add new things to those policies as new things come in. From a data point of view, we've come to the realization that we need to build a platform that spans both clouds. So our data teams are currently working on a multi-cloud data lakehouse platform with the aim to provide the same experience to any client that's using that platform. The goal with this platform will also be for teams to self-service and publish their own data sets in more of a sort of data mesh type approach. From a account point of view, we use a couple of different account types based on OU mappings. They're standardized guardrails in those accounts. And from a VPC point of view, we have a standardized structure as well. So all VPCs kind of look the same, they have the same naming conventions, which makes troubleshooting any network issues quite easy, or generally quite easy. And lastly, we work very heavily behind the scenes to pre-configure our machine learning environments on SageMaker, Studio, and Canvas. Our teams build a lot of lifecycle configuration to pre-configure environments for package management support, rotation of credentials. We create custom kernels for our teams so they don't have to pull the new libraries all the time. As I mentioned previously, we are of the view that the data science team should not have to spend in real time on infrastructure issues. It should just be able to go into a notebook and install what they need to install, etc. So we work heavily behind the scenes to enable that for our teams. Now I want to dive a little bit deeper. This is a 300 session after all. And I also wanted to call out that this is probably the only session today that doesn't talk about generative AI. But I did use generative AI to generate this slide using the Titan image generator, asking for a Rube Goldberg machine around cloud engineering and mining companies and so. So the automation platform is what we use kind of under the covers to enable and configure accounts for projects. It's actually a pretty simple platform in the scheme of things. It's a serverless platform. It's built on DynamoDB, Lambda, EventBridge, step functions, and CloudFormation. And it's account metadata driven. So on a nightly basis, we ingest data from the organization account. We then make changes to that account metadata depending on the project requirements, which triggers DynamoDB streams, and then triggers Lambda functions, which implement the various jobs that we have. Now the jobs are really opinionated small building blocks that we can reuse over and over again in any sort of fashion that we need to for the account at hand. The things we do with the jobs then is we deploy VPC endpoints en masse. We deploy access to CI/CD tooling, so if you want to deploy into the account using infrastructure as code, we give you access from your tooling into the account, and we even rotate credentials on a nightly basis from platforms that don't support OIDC. We also set up things like connectivity checking for networking. We support integration with our observability platforms. If you want to send your logs, you can enable that job and then tag your log groups, and it will just stream the logs straight into the observability platform for you. And we also have a job around SageMaker model promotion, which really ties into the MLOps side of things, which Romina discussed previously. This job allows us to take a model that's been trained in one account and actually move it into a production account for deployment. It can also move through multiple accounts as well, but this is just showing two. So the way this works, I wanted to show you on these slides, and there's a couple of accounts involved here. So top we got the automation account, and then we got a training account where the model will be trained using an automation role to access the account. We then deploy SageMaker Studio and VPC endpoints to enable the access. We then give the team access through IAM Identity Center, and we then set up the production account. We then link the accounts together in the metadata platform in DynamoDB, saying we're linking the training account to the production account. What this will do is we'll deploy a bunch of subscriptions in the account and listen for events using EventBridge on the model registry. The team will then go away and they will build their pipeline, or train their model, the normal steps you would expect, feature engineering, training and tuning, etc. Evaluating the model, and we're not too opinionated about what they use here. They can use step functions, we have teams that use Airflow, or SageMaker pipelines. But ultimately, they'll register the model in the registry. Now they can also use SageMaker Canvas, which is another tool used by citizen data scientists, which I will show in a bit as well. Now, the model will then be approved by a senior member of the team, typically, or the product owner. And with that, when that approval occurs, the job kicks in, and it analyzes the data that's been added to the registry, and then finds all the dependencies, all the hard dependencies, the actual model itself, any test results you've attached to the model, anything else that we want to keep and put into the production account. We then create a new model definition in the production account, and we link that model back to the new assets in the production account. The reason we do this is that we don't want to build a dependency between training and production. We don't want to be in a situation when someone deletes an image in the training account and it suddenly affects production. We then can deploy the model and inference pipeline and make it available for predictions. Now, there's a lot of things happening here, so I'm going to show you a demo how this works in the console. All right, so we're actually using Canvas here, which is a no-code machine learning tool, which can be used by citizen data scientists or other people. It's very simple to get a model trained. You take a data set and you say, I want to predict this column, and we'll actually build a model for you using autopilot under the covers. But it's a good tool for showing how the model, how the promotion process works. So I'm going to use the add to model registry functionality here, and we can see here, we're still in the training account, top left-hand corner. You can see the account, the training account, and there's nothing in the registry. I'm then going to add the model, and we can now see, once the model's been added, we have a new model appearing in the registry in the training account. The model is pending manual approval. It's got things like model quality data attached to it. It's generated by Canvas. It's got explainability things like SHAP values attached as well, and the model's now ready for approval. I'm not going to approve the model using the action menu here. It can be done through an API as well, and when that approval occurs, event bridge is going to fire, and we can actually end up in the automation account, which will then receive this event. So we're now in the automation account. We have step function here, step function workflow definition. We're now going to see a new execution of that step function workflow running. And it would run through the process that I explained before, analyze the dependencies, and then create the target model in the production account. So it's very quick. Now in the production account, we can see a new model has been added, a new model group has been added with the new model. And we can see that the model quality scores have been retained or copied across. We can also see the explainability scores have also been retained and are copied across as well. The model has actually been pre-approved as part of the pattern. We pre-approved the model in this case. And I'm going to use a notebook now. Typically this would be done in a pipeline, but notebook is more interactive for the demo. And using the SageMaker SDK to deploy this model, which has been promoted as an endpoint. So we're just using the SDK here. We're then using the Boto 3 library as well to get the package ARN from the registry. And then we're using the model package class to create the inference model here. You can see it here. And the serverless endpoint, which is now spinning up. And through the magic of video editing, about 2 minutes later, we have a running endpoint, and I'm now going to send an inference request to that endpoint. So we've taken a model from a training account, promoted it across, and deployed it for inference. If you want to do this yourself, there's some code here using the model package class from the SDK. The last challenge is on the citizen data scientists, and the way we've chosen to approach this is to create line of business level accounts to centralize the citizen data scientist for that line of business. The only difference between that account and the other one is that we also deploy some additional components. We deploy a POSIT Connect server, which allows us to publish Python applications without being web developers, to build a UI, and then using Canvas or Autopilot to build a model that can then be used by that UI. This supports experimentation and bootstrapping of projects before they become full-blown machine learning projects. Thank you.
Thank you, Marcus. Remarkable.
Oh.
And to wrap up the session.
So we're not quite...
to wrap up the session. Building MLOps capability is a gradual process that requires a culture of continuous learning and incremental progress. So, the recommended approach is to start small, identify those high-impact use cases, and build upon initial success. We learned that there is no one-size-fits-all blueprint of MLOps, as demonstrated in custom solutions built by Rio Tinto. The key considerations when designing how the MLOps architecture should look like for you should be assessing your in-house roles, existing roles and workflows, integrating with the current DevOps practices. They all will have to help you consider what architecture goes best. Your guiding principle should be clear goals and pragmatic steps to increase reliability, velocity, and collaborations in every step of the process. Technology makes innovation possible, but it's people who build a better tomorrow. Your time is now. On behalf of myself and Marcus Rosen, we thank you so much for listening to us today, and have a great rest of the day. Please take a moment to answer the survey as well.
Thank you, everyone.
Thank you.